Good morning. In my last class, I discussed about digital images, what is digital image processing and history of digital image processing. In my today's class, I am going to cover the topics on examples of fields that use digital image processing and key stages of digital image processing. So, the examples of fields that use digital image processing. The extent of image processing applications can be better understood by categorizing based on their sources. So, what are the sources of images? The principal energy source of images are electromagnetic spectrum, that is electromagnetic waves. So, what is electromagnetic waves? Electromagnetic waves is a stream of massless particles, each traveling in a wave-like pattern at a speed of light. So, this is the image of the electromagnetic spectrum where the spectral bands are grouped by energy per photon, starting from gamma rays, X-rays, ultraviolet rays, visible, infrared, microwaves and radio waves. Next is gamma ray imaging. Gamma ray imaging is widely used in nuclear medicine and astronomy. In nuclear medicine, the approach is whenever a radioactive isotope is injected to the patient, it emits gamma rays as it decays. These emitted gamma rays are passed through the patient and they are collected by the detectors in order to produce gamma ray images. So, this is mainly used in bone pathology. The figure 1 shows the complete bone scan of the human body. And another major modality of this nuclear medicine is positron emission photography. So, in this positron emission tomography, the approach is whenever a radioactive isotope is injected to the patient, it emits positron as it decays. These emitted positrons, when it meets the electron, both gets annihilated and two gamma rays are given off. These gamma rays are collected by the detectors in order to produce a tomographic image like this. So, figure 2 is an example of positron emission tomography. These kind of images are usually used to identify the tumors present in the human body. There are two tumors present in this figure. The first tumor is in the brain and the second is in the lung. And gamma ray imaging is also used in astronomy. A star in the constellation of Cygnus exploded 15,000 years ago, producing a superheated stationary gaseous cloud, so which we call as Cygnus loop. So, this is the image of the Cygnus loop captured using gamma rays. Next is the figure 4 is the image of gamma radiation at the valve of the nuclear reactor. So, you can observe that the gamma radiation is very intensified at the lower left end of this image. So, these are all the applications of gamma rays. Next is X-ray imaging. X-rays are oldest source of electromagnetic spectrum for imaging, and X-rays are widely used in medical diagnosis, industries and astronomy. X-rays are generated using X-ray tubes, that is a vacuum tube which consists of cathode and an anode. When the cathode is heated, it emits electrons. These emitted electrons flows towards anode at a very high speed, and whenever it hits the nucleus of the anode, it produces the energy in the form of X-rays. And these X-rays are made to pass through the patient and it is collected by the detectors in order to produce X-ray images. So, this is an image of the X-ray of the human chest. This kind of X-ray images are used to identify the fractures present in the bone. As well, another major application in the field of contrast enhancement radiography is nothing but angiography, which is also called as angiograms. This kind of images are used to identify the irregularities present in the blood vessels. The approach here is like this. Whenever a catheter is nothing but a small flexible hollow tube, whenever a catheter is inserted to the blood vessel and it is guided to the area to be studied, and whenever it reaches the site of investigation, an X-ray contrast medium is injected, and thus the image produced will be having the contrast blood vessel image, so that the radiographer can identify the irregularities as well as the blockages present within this blood vessel. So this image is an example of the angiogram where the catheter is inserted to the artery and vein of the human body. As well, the X-ray imaging is also used in computerized axial tomography. This is the computerized axial tomography image. So this is the image of the head slice which is captured perpendicular to the human body. So this gives the information of three-dimensional object, three-dimensional image inside the human body. And these X-rays are also used in industries. This is an X-ray image of electronic circuit board. Here, this image is used to identify the flaws present in the manufacturing, such as missing of components and broken traces. And the X-rays are also used in astronomy. This is the image of the Cygnus loop which is in X-ray band. So these are the applications of X-rays. Next is ultraviolet imaging. Ultraviolet imaging is widely used in lithography, industries, microscope, lasers, as well as astronomy, etc. And fluorescence microscopy is most widely used with ultraviolet rays. Fluorescence is invented in 19th century, and whenever an ultraviolet light is incident on a mineral, that is fluorosis fluorospar, the ultraviolet light itself becomes invisible, and this photon which is present in the ultraviolet light elevates the electron to its higher level, and when the electron releases to the lower energy level, it emits light. So this light shines with the dark background, helping the radiographers to visualize the images more appropriately. So this is the image of the, this is fluorescent microscopic image of the normal cone. This is the fluorescence microscopic image of the smut cone. So what is a smut? Smut is a disease that is caused in cereals as well in corns, grasses and onions, caused due to more than 700 species of parasitic fungi. As well, ultraviolet imaging is also used in astronomy. This is the image of the Cygnus loop in ultraviolet band. So these are all the applications of ultraviolet imaging. Next is visible and infrared imaging. The visual band of electromagnetic spectrum is most familiar for all our activities. So whatever we see in and around us is due to the visual band, that is visible band. This visible and infrared imaging is widely used in light microscopy, astronomy, industry, remote sensing, as well in law enforcement. Now look at these pictures. These are the light microscopic images. The figure 1 shows the anti-cancer agent which is captured using light microscope, and this is a cholesterol which is captured using light microscope, electronic circuit board, nickel oxide thin film, this is audio CD, and this is organic superconductor. All these are captured using light microscope. As well, visible and infrared imaging are also used in remote sensing. This is the image of the Washington DC. This is the satellite image captured by NASA's Landsat. This image involves the features such as buildings, roads, vegetation and the major river flowing through the city. And these images are captured in thematic band. That is, the first figure is captured with visible blue, second with visible green, third with visible red. And the fourth image is captured with near infrared, this one with middle infrared, and this image with thermal infrared, and this with middle infrared with higher wavelength. So these are the applications of visible and infrared imaging in remote sensing. This is the satellite image of America, which is captured during nighttime lights. This is another application of remote sensing with visible and infrared imaging. Now look at this image. This is the image of a Hurricane Katrina, the most devastating storm in recent memory in the northern hemisphere. This image was captured by NOAA's satellite, that is National Oceanographic and Atmospheric Administration. Next, visible and infrared imaging is also used in industrial application. Now, this image is used to identify the missing component, this image is used to identify missing pill, this is used to identify the unfilled bottles, and this is used to identify the gas bubbles present in plastic, and this is used to identify the burnt cereal, and this image is the eye lens image, and this is used to find out the irregularities in manufacturing the lens. So these are all some of the applications of visible and infrared imaging. Usually the satellite images what I showed here, Washington DC and this world map, is taken with infrared rays. Next is microwave imaging. The dominant application of microwave imaging is in radar. Radar has a unique feature that it is its ability to collect data irrespective of weather and ambient light conditions. Radars can also penetrate through clouds, they can penetrate through ice as well through vegetations, as well they can penetrate through dry sand. And these radars uses microwave pulses in order to illuminate the images, and the reflected waves are captured by the antennas but not using camera lenses as with other cases. And these are recorded using digital computers. Now look at this image. This is the image of mountains in southeast Tibet. This is captured by NASA's Landsat. The next is radioband imaging. Radioband imaging is widely used in medicine and astronomy. In medicine, it is mainly used with magnetic resonance imaging. This means that here in this case, the patient is placed in a powerful magnet and the short radio pulses are passed through the patient, and these pulses from the tissues of the patient is collected and detected, is collected by the detectors in order to produce the MRI scans. So these are the images of MRI scans. The first figure is the MRI scan of knee, and the second figure is the MRI scan of spinal cord. So this is all about the examples of fields that use digital image processing. Now let me take the key stages in digital image processing. Next is key stages in digital image processing, that is the fundamental steps involved in digital image processing. First is image acquisition, next is image enhancement, image restoration, morphological processing, segmentation, object recognition, representation and description, image compression and color image processing. These are the steps involved in digital image processing. First is image acquisition. Image acquisition could be as simple as being given an digital image. Okay. So, this image acquisition performs some pre-processing operations like scaling of the images, etc. Next is image enhancement. Image enhancement is the process of manipulating the image so that the resultant image is more suitable than the original image for a particular application. So, this is the original image and this is the enhanced image. There are different enhancement techniques. The enhancement technique which is more suitable for Xray band might not be a best approach for infrared band. So, next is image restoration. Image restoration also deals with improving the quality of the image by removing noises, and this is the original image, this is the restored image. Unlike image enhancement which is subjective, image restoration is objective. That means it uses mathematical and probabilistic model for representing the images. Next is morphological processing. Morphological processing is the tools used to extract the components for representation and description of shapes of the objects. So, there are different morphological algorithms which can be used according to the application. Segmentation is a process of partitioning of an image into its constituent parts and objects. Segmentation can be categorized into two types, that is object based segmentation and region based segmentation. Next is object recognition. Object recognition is nothing but assigning a label to the object which is been recognized or which has been identified. This is mostly used in law enforcement, that is to recognize the vehicle or to recognize vehicle number, like that, etc. Next is representation and description. There are two types of representation, that is boundary representation and region representation. If the raw pixel data constitutes the boundary of the object, we say that a boundary representation, and in this approach the focus is towards the shape of the object. The next is region representation, where if the raw pixel data is inside the region of the object, inside the object, we say region representation. This approach is suitable when the focus is towards the internal properties of the object like texture of the object, etc. Description is nothing but extracting the attributes from the images in order to identify the features. Next is image compression. As I told, high quality images require high memory to store the data. So, image compression techniques are used to minimize the data storage for a particular image. There are different image compression techniques like JPEG, PNG, TIFF and GIF. As well, image compression techniques are also used to reduce the bandwidth while transmitting the images. Next, color image processing has gained its importance because of its significant use in digital images which is used in internet. And this color image processing is used to identify the objects present in an image. So, these are the different steps which are involved in digital image processing. So, this is all about the fundamental steps that is involved in digital image processing. Thank you.